So as we move on, we're going to be looking at a new unit, probability. Probability is all about chance and likelihood. How do we measure whether or not we expect something to occur? Or how do we measure the chances or the likelihood that something occurs? We'll start with some terminology, and we want to make sure we get this terminology correct. An experiment is any repeatable process that gives rise to a number of different outcomes. So, rolling a dice is an experiment. Flipping a coin and recording what face is pointing upwards is an experiment. And on the screen, I have a few more examples of experiments. An event is a set of one or more of these outcomes. On a dice, getting a score of 1, 2, 3, 4, 5, and 6 are each individual outcomes. But if I grouped these outcomes together, if I said what's the probability of getting an even number, well, getting an even number is what we'll refer to as an event. It's a collection of outcomes. A sample space. This is the full set of all possible outcomes. Sometimes these can be written as a list. Sometimes we might need to make a table or diagram to demonstrate all of the possible outcomes. Okay, so let's have a look at these in specific situations. And we'll start off with what's usually the most basic of situations, flipping a coin. So, in this situation, flipping a coin just once would be the experiment. And there are only two possible outcomes, heads and tails. Now, the event would have to be a bit specific about what the event is. What are we actually measuring? And the event could possibly be getting a tails when we flip the coin once. Just as easily, the event could be getting a heads when we flip the coin once. Now, the sample space, once again, is slightly trivial because there are only two possible outcomes. So our list of all the possible outcomes is simply heads and tails. How does that change if we make the experiment a little bit more complicated? Now the experiment is flipping a coin 3 times. And there are numerous outcomes that we can have. We can have 3 heads in a row. We could have heads, heads, tails, heads, tails, heads, heads, tails, tails, etc. These are each individual outcomes. Now, the events can be more numerous. The event could be getting at least 1 heads. The event might be getting the same result on the coin all 3 times. We can get quite creative with the events in this case. And the sample space is a list of all possible outcomes, all of the combinations that we might have. And in this particular scenario, there are 8 possible outcomes as shown below. Okay, rolling a dice, another standard probability scenario. The experiment is rolling the dice once. The outcomes are 1, 2, 3, 4, 5, or 6. An event, we also have quite a few options for events here. It might be rolling an even number. It might be rolling a prime number, rolling a multiple of 3, rolling a factor of 12. We can get creative with these events. The sample space is the list of all the possible outcomes, and it's 1, 2, 3, 4, 5, and 6. So once again, this is quite a basic experiment. What would happen if we made it a little more complex? So rolling a dice twice, and hopefully you would be a bit more familiar with this from GCSE. This was a standard GCSE question. What would happen if we roll the dice twice, and what's the probability of specific events? So the outcomes are a 1 on the first dice, a 1 on the second, a 1 on the first dice, a 2 on the second, a 1 on the first dice, a 3 on the second, etc, etc. And that can get to be quite a long list. We'll look at that in a second. Events. A lot of students assume that we're always adding the scores together, so just be careful whether or not it's specified what you're doing with the 2 scores. But an event could be adding the scores and getting an even number, adding the scores and getting a prime number, finding the difference of the scores that you achieved on each dice, and getting a multiple of 3. An event might be simply to record the highest of the two numbers. An event might simply be one of the dice showing a 4. Now the sample space, it's hard to list. This is definitely an instance where you would want to make a table. You would want to make a diagram to show all the possible combinations. We'll use the rows for dice 1 and the columns for dice 2. And depending whether we need to add or subtract or multiply the score from each individual dice, we can then fill in all the possible score combinations we might get. Okay, another example, spinners. Spinners are quite commonly used in questions and scenarios that are set up around probabilities. The experiment is spinning the spinner once. For the outcome, we could either refer to the numbers or we can refer to the colours. So the possible outcomes are 1, 2, 3, and 4, or red, yellow, green, and blue. In this case, the event might be rolling an even number, or rolling a prime number, or rolling a multiple of 3, or rolling a primary colour, or rolling a yellow, or rolling a green section. Either of those could be events. The sample space, if we were going by the numbers, would be 1, 2, 3, and 4. I want you to be very careful in this kind of scenario. The probability of getting a 1 is not the same as the probability of getting a 2. These are unequal probabilities. These probabilities are not distributed equally amongst the possible outcomes. So just be careful with that when it comes to any probability calculations. Once again, we can get more complex and we could spin the spinner twice, and the outcomes would be a combination of two individual outcomes. The events can get more complex here as well. And just a couple more favourites that come up in questions. Questions around a deck of cards. Now, a deck of cards, a lot of students tell me actually that they're not familiar with a deck of cards, so I've made sure to put this on the screen for you. There are different values for the cards, ranging from a king to a queen to a jack, and then we have the numerical values, 10, 9, 8, all the way down to 2, and an ace, which usually represents the number 1. So there are 13 cards in each of these suits. The different symbols are called suits. Now the suits, going from top to bottom, are clubs, spades, hearts, and diamonds. So 13 cards, 4 suits. There are 52 cards within a deck. The experiment, picking a card from the deck. So just picking a single card from the deck. The outcomes are each of the individual cards. It might be the ace of clubs, or the 2 of hearts, or the 7 of diamonds, or the queen of hearts, or a picture card, which is any of the king, queens, or jacks. It might be getting a 6. Lots of events that we can pick from a deck of cards. The sample space is a bit too hard to demonstrate, which is why I've actually just got it on the screen for you. That is the sample space. That is all the possible outcomes we can get from picking a card. Okay, we can get more complex and say that we're picking 2 cards from the deck, and the outcomes become more complex as well. What's the probability of picking a card from the same suit twice? The probability of picking a 7 twice. The probability of picking a number less than 4 twice, etc. So yeah, we can get very creative with the events around here. Familiarize yourself with a deck of cards so you can respond to these questions. Okay, so now we've got the terminology down. Let's just try a couple of examples and see where that fits in. 2 fair spinners each have 4 sectors numbered 1 to 4. The 2 spinners are spun together and the sum of the numbers indicated on each spinner is recorded. Find the probability of the spinner indicating a sum of exactly 5. Okay, so the experiment here is that 2 spinners are spun together. The event is the sum of the numbers being exactly 5, or the sum of the numbers being more than 5. So those are our 2 events. Now the outcomes are displayed in the sample space diagram as shown, and those are all the possible outcomes. So we're going to be able to use those to calculate the probability of these events. The probability that I get a score of exactly 5, and that would be these outcomes from all the possible outcomes. There's 4 of them out of a possible 16. The probability of getting a score of exactly 5 is going to be 4 over 16. So make sure that you're using this notation. We write a capital P and open up some brackets, and we write the event inside the brackets. So the probability score of 5, close bracket, equals 4 over 16. 4 over 16 cancels down. We've got 1/4. The second event that we're finding the probability for is the probability of a score more than 5. A score more than 5 is all of these outcomes, and there are 6 of them in total. 6 over 16, that cancels down to 3 over 8. Probability of a score more than 5 equals 3 over 8. Okay, and that's what we'll need to do. We're going to make this sample space diagram for ourselves so that we're looking at the sample space. We can pull out all of the outcomes that match the event we're working with, how many outcomes we were interested in, divided by how many outcomes there were altogether. And I'll quickly go through a question that uses a grouped frequency table for you to generate probabilities from. So, the table below shows the times taken in minutes for a group of students to complete a number puzzle. A student is chosen at random. Find the probability for a group of students to complete a number puzzle in under 9 minutes or in over 10.5 minutes. So, the experiment here is that a student completes the number puzzle. The events could be any groupings of these completion times, and the sample space is the table itself, all of the possible outcomes from the time recorded for the student to complete that puzzle. Now, in this particular question, the first event we're going to calculate is the probability that a student is chosen at random and they complete the number puzzle in under 9 minutes. So that event is a combination of 2 of the possible outcomes. And we're going to use the frequency here to calculate our probability. So the frequency is 19. There were 19 of them that completed it in less than 9 minutes. And that's 19 out of a total 40 students involved in the first place. So 19 over 40. The second event is the probability that we pick a student at random and they finished in over 10.5 minutes. Okay, 10.5 minutes is going to be slightly more difficult to calculate since there is no interval that ends at 10.5 minutes. But we're going to use some approximation. We're going to use some proportional reasoning to try and estimate how many of them would have been above 10.5 minutes. We're going to look into this group first, this group right in the middle that starts with 9 and ends with 11. There are 12 students within this group. Let's see if we can split them up a little bit more. 10 is right in the middle, and 10.5 is 3/4 of the way along. If I've split this group up into quarters, those 12 students, we can assume that they're evenly spread and there's 3 of them within each of these quarters. I'm interested in the probability of 10.5 and above. So I'm going to estimate that there's 3 of them in between 10.5 and 11. And I'll add that on to the other 9. The probability that a student is chosen at random and they took longer than 10.5 minutes to complete the puzzle, we'll add 3, 5, and 4. That gives us 12 over 40, which cancels down nicely to 3 over 10. So a probability of 3 over 10. Okay, so we've looked at the terminology we should be using, events, experiments, outcomes, and sample spaces, and how we can use those to actually calculate our probabilities. So definitely this new terminology and the technique that I've shown you should be added to any GCSE knowledge that you came with, and from there you should be able to comfortably calculate some probabilities. So I'll leave you now to go and get some practice, and we'll be back here to look more at Venn diagrams.